Hi, in this video we are going to be looking at the combined gas law. So before we go into that, we need to understand the other concepts, which is number one, we have established that gases have these four quantities. So we can take a look at the pressure of a gas, we can measure its volume, we can count the number of particles it has, and we can look at its temperature. So P, V, N, and T. And then you have to remember that we have the basic laws, the basic gas laws, which are the Boyle's law, Charles's law, and Gay-Lussac's law. And again, the way you kind of connect this to the concepts of the measurable quantities is to think that these laws are really just looking at two variables out of those four. So for example, Boyle's law kind of looks at what's the effect of the pressure to the volume, or what's the effect of changing the volume into the pressure. So therefore, again, just like in any experiment, if you want to take a look at the relationship between these two variables, then again, you have to control the other variables because you don't want them to be interfering with your experiment. So therefore, if you are looking at pressure and volume, you have to keep the number of particles and the temperature constant, right? And then Charles's law is kind of like looking at a different thing. It looks at the temperature versus the volume. And again, because good experimentation dictates it, you must keep the number of particles and pressure constant. And then in Gay-Lussac's law, you're looking at pressure, the effect of pressure into the temperature, and vice versa. So therefore, because you're looking at P and T, you have to keep N and V constant. And again, it's easier to kind of study the whole, look at the gas laws coherently if you just think that these iterations, these gas laws, are simply um, looking at the variables and picking out two and investigating two out of the four. So I'm investigating P versus V, that's Boyle's law. If you're investigating V versus T, that's Charles' law. If you're investigating P versus T, that's Gay-Lussac's law, right? And in fact, you also have Avogadro's law, which is looking at N and N versus V, but that's not important for the combined gas law. For the combined gas law, we only take a look at these three: Boyle's law, Charles' law, and Gay-Lussac's law. And if you think about it, um, just like the name implies, combined gas law is a combination of these three laws. Okay? What do you mean a combination, sir? So here, if you look at Boyle's law, you're keeping N and T constant. In Charles's law, you're keeping N and P constant. In Gay-Lussac's law, you're keeping N and V constant. So in other words, in all these three laws, you're keeping the number of particles constant. Okay? So therefore, in Boyle's law, it might be keeping temperature constant, but here it's pressure, but here it's volume. But the common ground between these three laws is that they're keeping the number of particles constant. So therefore, conceptually, we can merge them and have a framework where instead of Boyle's law, Charles' law, and Gay-Lussac's law, we kind of have a law where what we keep constant is only N. Okay? So therefore, if only N is kept constant, so therefore, P and V are free. P, pressure, volume, and temperature are free to have any value that they can. Okay? So that's the idea behind the combined gas law. You're kind of combining the Boyle's law, Charles's law, and Gay-Lussac's law by looking at what is the kind of commonality between them. And the commonality between them is that they have the same, they have to keep the number of particles constant. So now you have this law where its focus is to kind of look at the relationship between the three: pressure, volume, and temperature, when you have the number of particles constant. In the next video accompanying this video, we will formally look at the formulas associated with the combined gas law in relation to Boyle's law, Charles's law, and Gay-Lussac's law.